Alright, we're going to finish up section 1 here in chapter 5 by talking about something that you're going to see probably in your second semester of calculus. In the second semester of calculus, they typically go over a chapter on what's called the techniques of integration. And there are different kinds of techniques of integration, and this will make more sense to you later on when you're in the first semester of calculus. But there are techniques known as integrating by parts, different powers of sine for cosine, and also one that's called trig substitution. And that's what I'm going to talk a little bit about today. I want to look at these three radical expressions, and these three radical expressions appear quite a bit in integrals in your calculus too. So I would like to consider the radicands for each one and kind of compare them to at least one side of one of the Pythagorean identities. The u squared plus a squared is very much like tangent squared x plus 1. Now remember, a is a constant, so that's like a 1, and u would be considered in this case the tangent of x. A squared minus u squared would be 1 minus sine squared x. Now we know that tangent squared x plus 1 is secant squared x, and 1 plus sine squared x is cosine squared x. And then here, u squared minus a squared, where my u would be the secant of x minus 1, and this of course is equal to the tangent squared of x. Now I'm going to rewrite this expression, and I'm going to try to write it as a function of theta, where theta is a first quadrant angle. Therefore it's going to be positive no matter which trig function we're doing with, and we're going to use this as the substitution. Now in the calculus, you're going to have to be able to look at this and realize what substitution you're going to use. If they're not going to give you the substitution, you're going to have to come up with this. But in this case, this problem starts off a little bit easier. So we're going to make the substitution into the square root of x squared minus 121. I'm going to plug this in right here, in for x, and that would be the square root of the quantity 11 secant theta, quantity squared minus 121, which would be the square root of 121 secant squared theta minus 121. And then I'm going to factor out the 121 that is common to both, and I'm going to get 121 times the quantity secant squared theta minus 1. See that guy right there? Secant squared theta minus 1. And as I mentioned before, that's the tangent squared of theta. So I'm going to make another substitution here. I'm going to write in for secant squared theta minus 1, tangent squared theta. Now because theta is a first quadrant angle, the tangent of theta is going to be a positive number. So I'm going to be able to rewrite this without absolute value bars as the square root of 121 times the square root of tangent squared theta. That would be 11 tangent theta. Alright, now you say, well, how is this going to help me? Well, let's set this up. Remember our original substitution here. I have x is equal to 11 secant theta. I have the secant of theta is equal to x divided by 11. If I construct a right triangle, because I know theta, that's supposed to be a right triangle. See if we can do a better job. That looks a little better. And put theta right here. The secant is the hypotenuse over the adjacent. And this, of course, is the square root of x squared minus 11 squared, or 121. That's our guy right there. So what I'm asking you to do is I'm asking you to rewrite this so that we get our expression as a function of theta here. So what is I lost my spot here. I have the tangent of theta is equal to the square root of x squared minus 121 over 11. And then that would give me, if I multiply both sides by 11, 11 tangent theta is equal to the square root of x squared minus 121. And that is what I wanted to do. I wanted to write this expression here as a function of theta, and there it is. Now you say, I just don't see the use of this. Well, you will in Calc 2, because with these kinds of substitutions, you're going to get an integrand that's going to be easier to work with than the one that you start with. You just have to learn a little bit more about the trig, and then of course apply this in your Calculus 1 and Calculus 2 classes. But I just wanted to show you a little bit here. And we're not going to do a ton with this right yet, but you will have this a coming. Just want you to be aware of that. So practice, practice, practice.